We're going to get started because we have a packed agenda. So thank you all for attending our webinar called API 535, Burners for Fire Heaters, Burner Components. I'm Siddharth Garg. I'm a process engineer at Furnace Improvements, and I will be your facilitator today. In a few moments, I will hand it off to our speaker, Ashutosh Garg, who will lead the training. Ashutosh Garg is the founder and vice president at Furnace Improvements. He has over 50 years of experience working with fired heaters. Over his career, he has held positions as a process engineer at companies such as Shriram Chemicals, Engineers India Limited, and KTI before starting FIS in 1996. He has also published several articles on fired heater and holds 3 patents that you can see on our website. Okay, just a couple of notes before we get started. We're going to leave some time at the end for questions from you. So please submit your questions and we'll leave a couple minutes for us to review them. This is a great chance for you to get personal guidance or specific help that you might need. We are using a presentation software, so I would recommend maximizing the window for Ashutosh Garg, and you can do that by double-clicking his screen. And finally, if you have other questions, you can always reach out to us. Our website is www.heatplex.com, and we respond very quickly. So if you have any questions or want more support, please reach out to us. Okay. So before we get started with the presentation, we're going to ask just a couple of questions so we can learn more about you and your experience with burners. So I'm going to start with a simple poll question. And this one is, did you join us for our first Burner Series Part 1 webinar? We're just curious if we have newer folks or we have some people who have been part of this Burner series. All right. It seems like we have some people who already attended the first few webinars and some new people, so welcome. Okay. I'm going to do just a couple more. This one is about API 535, which is a great resource. And we want to know, have you read API 535? Because our presentation is heavily based on this document. Okay, we have a few people who've read it and a few people who have not read it yet, but you're in the right place. We're going to talk about it. All right. Yeah, I'm going to share the results. So we have this is a good opportunity for us to share the knowledge in this document. Okay, and then one last question. What do you want to get from today's session? And this helps us understand, how to tailor the presentation so it most benefits you. All right, I'll give maybe a few more seconds and then I'll close this poll. Okay, I'm going to close it and then we can look at the results. So understanding burner components, which is great. That's the focus of today's webinar. Troubleshoot common issues faster. I'm sure we'll go through some of that content as well. Improve efficiency, reduce emissions. All right. Well, thank you for your active participation. And now, without further ado, I'm going to hand it off to Ashutosh Garg.
Thank you, Siddharth. Good evening, friends. I'm doing this webinar from our Indian office. This is our first webinar for this year. Our company has been in the business for almost 30 years now. Next month, we will complete 30 years in business. We mostly work on design, engineering, and supply of fire heaters. We also supply new ultra-low NOx burners for fire heaters, steam reformers. And this webinar, what we are going to be doing, has born out of my experience of dealing with customers like you for more than 50 years. So thank you all. More than 120 people registered for this webinar. And today we will be talking about API 535. API 535 is a standard developed by API. I will go in a lot more details. The first edition came out in 1995, and 2 years ago they came out with the fourth edition, so we'll talk about it. And we'll talk about how we can improve the burners. If you know a little bit more about burners, you will be able to buy better burners. Also, as Siddharth said, we will have some time for question answers. So keep on sending your question answers to him, on this thing. So before I start the presentation, I do want to spend a few minutes for introducing our company. My team of engineers and drafting people have worked very hard for the last 4 weeks for building this presentation. So I have to do this little bit of marketing, I should say, or infomercial for furnace improvements. As I said, we have completed 30 years. We have got 2 offices. Our main office is in Noida, India now, which started in 2005. And we have an office in Sugar Land, Texas, where I and other people work. Most of our business has been improving performance of existing heaters. We try to breathe new life in the furnaces. And we have a very contrarian approach. So based on that, we have challenged conventional wisdoms. And that's why we have 3 patented technologies. And today I will only talk a little bit brief about inclined firing technology because it is related to the burners. Other than that, we have split flow and dampers, efficiency improvement dampers. So what we can do for you, we can provide you with the best burners for your fire heaters and reformers. The way we do it is we match burners and furnaces to get you the peak performance. And we have done almost 50 projects replacing burners in fire heaters. That's our record. We always try to provide you with the value-added solutions. And our company is the only company which works on existing fire heaters. Most of the companies, they try to sell you new fire heaters. And we typically work with end users most of the time, like a doctor-patient relationship. And our philosophy is do it once, do it right, and give you the best quality work. If you want the best burners for your fire heaters, steam reformers, come to us. Burners are the heart of fire heaters, and I think we are the best heart specialists with more than 50 years of experience. As far as our experience is concerned, we have worked on almost all types of refinery heaters. Reformers, crude heaters, hydro treaters, cokers, steam methane reformers, waste heat boilers, SCR units, ultra low NOx burners. So we can work on any heater if you want. We would like to take this opportunity to thank our clients for the past 30 years. They have put their trust in our services and products. We have been fortunate to build long-term relationships with most of our clients. And the way we survive is through repeat business. You can see we have worked with Philips 66, Countrymark, Citco, Delec. Most of them are US based, but we have worked for some companies in Middle East, in India. Uh, that's where our base is. Worked with Indian Oil, Thermax. Recently, we worked with Mangalore Chemicals and Fertilizers, BHEL, Petrojam in Jamaica. We have done work for Brunei Fertilizers recently, training over there. We have worked with INA in Europe. So we have worked all over the world. And there are some clients with whom we have worked for more than 20 years, especially Phillips 66. They are our largest client for the last 20 years. And we are almost like their in-house engineering company, furnace fired heater company. So Siddharth has recently joined us in the business, and he is the organizer, co-organizer of the webinar today. So he developed this fire heater operator training for plant operators. It takes about 3 hours to complete. You can do it in multiple sessions. It's priced almost free. Almost free, It is $95 per person, which, we can't even recover money. So it is the best investment you can make in your operators. If you want to have no accidents in your plant, training is the best option. So I would strongly recommend asking your operators in your plant to go for this training. That would be really, really helpful to you. Uh, Let me tell you about our team. We have got about 35 employees. We handle all aspects of process, mechanical design, CFD modeling, structural design, drafting. We are almost like a full heater service company. We have handled projects, turnkey projects, including heater erection. We have supplied a heater in 6 months. Nobody else could do it. You know, we installed a hot oil heater for Sasol, which nobody else could do it because the space was very tight. We have installed an air preheater in an inclined configuration, which is probably the only installation we'll be working for more than 10 years. So we have done lots of new things, challenging things, and we have been successful. And I want to thank my team for working with me and Siddharth and executing tough projects with us. We have used CFD modeling for solving many heat and flow distribution problems. We perform CFD modeling of burners before we install them in the furnace to ensure that there is no flame impingement. We have done more than 50 projects to solve airflow distribution, combustion, fan system losses. And in many cases, we have done CFD modeling on our own actually to ensure that our approach is correct. Uh, as I said, we have 3 patented technologies, but today we will talk only about inclined firing technology because that is related to burners. And most of the time in a vertical cylindrical heaters, you fire burners vertically up. But what we realized is if you fire them at an angle of about 3 to 5 degrees or even 7 degrees, we have been able to eliminate flame impingement and lower the tube metal temperature by 200 degrees F. So if you are thinking of replacing burners in your fired heaters, I would suggest use this revolutionary technology. It will cost very little for you to modify the burners and get much, much better results. So that would be a good investment for you. All right. Okay, let's come back to the webinar, API 535. So API is American Petroleum Institute. It's a body which comprises of refiners, engineering companies, and fired heater suppliers, burner suppliers, basically vendors. So 3 type of companies are associated with API. The membership is free. They meet twice a year, and you can also participate if you like. And they review technical specifications. They review technical specifications of almost all the refinery related equipment. Recently, they even developed a specification for steam methane reformers. So API 535, I would strongly suggest that you should buy a copy. Buy a copy of API 535 and API 560. Those are the two very important documents for you, which will help you, get the basics of fired heaters and burners. That will be really, really good. And they keep on updating the standards every 5 to 6 years. I mean, that's typically their cycle. Sometimes it takes longer. So what we did was we thought, why don't we teach API 535 to our customers or users? So we devised this 8-part series, and my team broke it up. The first one was burner fundamentals, and we covered section 1, 2, 3 from edition 3rd. This was done in October in 2 sessions. We could not finish it in the first session on October 7th. So then I did a makeup session to carry out the remaining work, remaining material. And this is today we'll be covering about burner components. Then next session, we will try to do it. Burner selection, burner firing will be the 4th one. Low NOx burners. Then we'll cover about burner maintenance, operation, burner testing, and burner troubleshooting. So if you have missed the section 1, I suggest you go to YouTube and check for furnace improvements. Both the webinars are posted over there. And you can also watch my other videos on different aspects of fired heaters. And if you have any suggestions for us, we are always looking for communication with our customers. So if you have any suggestions, if you want me to cover a specific topic, let me know and I'll be more than happy to work on it, So as I said, today we'll be covering burner components. Just wanted to give you a little bit history of API 535. Originally, fired heater technology was held by refineries, large refineries, majors like ExxonMobil, Shell. Those companies had the fired heater knowledge, and even the burner knowledge they had. Then they passed it on to engineering companies like Foster Wheeler, Lummus, and then from Lummus it went down to second run companies, and now I think there are about 25 companies. So similar thing happened in burners. Actually, burners were mostly there are still only 3 companies in the world who specialize in fired heater burners: Jones Inc., Zico, and Calidus. They are all located in Tulsa area, Oklahoma, in US. So most of the knowledge in API 535s have been supplied by the vendors, burner vendors. They are the experts in their field. So they have developed this specification. The first edition came out in 1995 for fired heaters. Then industry changed, and they added some more in about 10 years, then again 8 years. Now from 3rd edition to 4th edition, we have compared, and they have deleted a lot of information from 3rd edition when they brought out the 4th edition. So it is your choice. You can go and check 3rd edition if you want more information about piping and other things. If you want the latest one, go for the 4th edition. And burners are one component that have gone major changes in the last 50 years. Mostly because of NOx emissions. Burners were most unchanged from, I would say, 1920s to 1970s. They did not undergo any change. They were the same. But after 1970s, when EPA discovered that NOx, oxides of nitrogen, are harmful to the general public, they started acting on it, Clean Air Act, and that's when the industry started working, the combustion industry, the burner industry started working. And there have been at least 4 or 5 generations of burners in the industry today, And with every new development, new technology comes in, so standardization is even more difficult, What you are seeing in maybe fourth edition, maybe half of it is already obsolete, And burners are very, very critical in fire heaters. Although they provide the heat for the operation, they are critical because they can cause a lot of problems. They can cause hotspots, they can cause coking, they can cause capacity limitations, high emissions, and now we are talking of greenhouse gas emissions. So a lot of things are there. So it is always good for you to understand, hey, what are the functions of the different burner components. So let's talk about burner components. I wanted to do a poll to find out how many of you know the list which I have put over here. But burners have a lot of components now, So let's start with plenum or wind box as we call it, air registers, burner tile, fuel gas tips, fuel gas risers and manifolds, viewing ports, burner piping, pilots and igniters. What is missing in this is oil firing. We are not talking of oil firing because I believe most of the refineries have stopped burning oil. Maybe a few refineries in the world are still burning oil, but most of the refineries have stopped burning oil because of pollution. So we'll try to focus on gas firing today. So these are the components. So let's talk about air plenums or individual wind box. The function of wind box is to supply and distribute combustion air. We can have 2 types of plenums. We can have a single plenum, or which we call wind box, basically for single burner. And a lot of times we can have multiple burners in a single plenum or single housing, and that is called plenums actually. So APA 535 suggests the casing thickness to be at least 10 gauge. So if you are buying burners, please, you can specify, hey, I need at least 10 gauge thickness for the plenums. These plenums or wind boxes may be lined internally to meet the noise limit, depending on what noise limit you have. In US, we use 85 dBA. In Europe, they use 75 dBA, so depending on what are the noise limits. So, and then you have a muffler. You can see the muffler over here. This is the muffler to reduce the noise. We also have a bird screen to prevent the egress of bird or ingress of bird into the wind box. Normally it doesn't happen, but some people have started providing the bird screen. So that's the air plenum we have. And then comes the air registers. Air registers are used for controlling combustion air to the burners. Most of the time they are manual. Some people have tried using automatic controls in some small, highly specialized heaters. But I mean, what we see in the industry is still very crude, I should say, all manual controls. And generally, these air registers need to be operated to control the oxygen in the flue gas. So API 535 talked about three types of air control devices. Uh, I could only find two. I have not seen the third one, so I kind of deleted it. But you can see the multiple damper blades and the air control handle in this slide, which is one of the common ways of controlling combustion air. Uh, Very common design for natural draft burners uh, was pioneered by John Zink and Zico. Uh, and this basically consisted of two concentric metal cylinders with the slots, one fixed, one rotating, and slots were aligned by the rotation. And it has been one of the most popular. If you go to any old refinery, you will still see these type of air registers, made out of carbon steel for most of the time. And some of them are working, some of them are not working. I don't want to go into detail of pluses and minuses. We will go maybe in that troubleshooting or problems when we talk about that. And this is the another design, which is basically the you have a wind box, and then you either have a single blade or a multiple blade. This is another common design, as I said. So,
Should we do one quick poll question? Okay. So we have two quick poll questions specifically on air registers. So we'll launch them because the next slide is going to give you the answers. So this is the right time to do it. Okay. So this one is about air leakage, and we just want to poll the audience. Which air register type do you think typically has the highest air leakage when it's closed? All right, I'll give maybe just a few more seconds. Okay, get your votes in. All right, I'm going to share the results. All right. Okay, we think it's concentric circles, concentric cylinders. So we'll find out in the next slide if that's true. And then we're going to ask one more question. And this is about more what kind of air register issues do you experience in the field? So this is really for us to kind of understand too. If you do operate with air registers, do you experience any of these issues? If they're hard to tune, do they stick? Is it high maintenance? And this will be a good chance for you to also see from your fellow attendees, do they experience the same issues? Okay, just a couple more seconds and then. Okay, last chance. Okay, I'm going to share the results. So it looks like the two most common issues are like harder to move mechanisms. Maybe sometimes they stick or seize, or just poor controllability. It's hard to tune to the exact, the exact opening that you need. All right, thank you. Yeah, thank you for participating. I'm going to hand it back to Ashutosh, and then we'll continue the presentation.
Thank you, Siddharth. All right. So let's move on to the next slide. So I think the audience came out with the correct answer. Most of the A registers, these are the design considerations for API 5 from API 535. Designed to be fully open at peak firing with maximum airflow. That is, you want them to be fully open. A lot of times you can have a pressure tap, and that can help you in balancing the burners. If you have air leakage from closed registers, it's going to be reducing your efficiency. Typically from a damper type of registers, you have got a much lower leakage than circular registers, And they are also easier to operate. The damper type registers are easier to operate. We can even improve their performance by adding sealing strips and tighter tolerances. So we can try to bring down to almost like 3%, less than 3% leakage when they are fully closed. That's a good number to go by. What all do you want? You want the air registers to be easily accessible to operators. That's a very important parameter, A lot of times we miss some of these things, and operators either don't have room to operate or the handles are too high. Both type of things can be. You also want to have clear indication linked to the blade's position. You want to make sure that the position indicator is indicating the damper opening correctly. And then you want to have a locking mechanism, So you don't want to have the damper closed automatically or open automatically. So have a locking mechanism, So these are some of the things you will see from API 535 that will help you in getting better burners. If you have a damper type registers, you can add bushings, packing glands, ball bearings. You can use corrosion resistant materials. You can have opposed blade operation for better control. So all these type of things you can add to improve your existing new burners. The standard is basically for new burners. So you can add these things to improve the performance. Next, we would want to talk about burner tile. The burner tile is usually round or rectangular depending on the type of the flame you are trying to produce. What are the functions of a burner tile? The most important is controlling mixing of fuel and air. Another one is enabling flue gas recirculation to reduce NOx. Refractory in the burner tile provides a stabilizing surface for the flame. And the main important thing is they provide the desired pattern to the flame. You want a round flame, you will have a round tile. You want to have a flat flame, you will have a rectangular tile. So these are the different functions of tile. Most tiles are manufactured out of hard refractory rated for 1650 degree centigrade or 3000 degree F. typically 60% alumina or even higher. Some people want to minimize the number of tiles. I think in some respect it is better, but these days the tiles are so big that it is almost impossible to make them in single piece. But you can try to minimize the number of tile pieces, so that way they don't go out of alignment. This is a recommendation from API 535. If you have a normal gas firing, you may go for 60% alumina. Oil firing, but vanadium less than vanadium and sodium less than 50 ppm, 60% alumina will work. But if you have sodium and vanadium more than 50 ppm, then they recommend 90% alumina refractory. Another important component for burners or low NOx burners is fuel gas risers and distribution manifolds. So one of the important things you want to have is these, either whether you have an oil gun or you have gas risers, they should be easily removable. You don't want them to be taking a lot of time, because a lot of these things get coked up very fast. So you want to have a flexibility to clean them up. So in some burners, we may have a central gas tip. This is mostly in standard burners or old burners. Here you can see the staged gas tips over here also. So primary gas tips, staged gas tips. And these gas tips may have very small holes, usually without an internal orifice. Some burner vendors may provide you with a dual orifice. We'll just talk about it in a minute. But most of the time it's a single orifice or single gas tips. So this is the drawing of a tip we provided to one of our clients as a replacement. So you can see there are 3 holes over here and 1 hole in the horizontal direction. So this horizontal port is called ignition port, and the other 3 firing ports are called the firing ports. So the other 3 holes are basically the. And these days, since we have multiple tips, you want to have very small tip diameter so that it does not get heated up too much. If a tip size is very big, it will receive a lot of heat and then it will coke up. So some people, if your burner capacity is very small, may end up providing another orifice in the fuel gas line or fuel gas riser. So you will have a double orifice. You can do it if you've got no other choice, but typically, normally you don't go for double orifice. You want to have all the pressure drop in the gas tip only. I just told you about the ignition port and the firing ports. You can see over here. Ignition ports are also important. We will talk maybe more about them in the troubleshooting, section. So make sure you attend my. Then other important components in burners are viewing ports. You want to have a viewing port for viewing pilot as well as main flame. You also want to have a manual lighting port for ignition. So even though you may have electronic ignition on your pilot, you still want to have a manual facility. And then there are things like electronic ignition, flame scanners, etc. This is the down-fired burner. I just included it. They are very special in steam methane reformers. They fire downward, which is pretty difficult because flue gases have a tendency to rise. You want to make sure your flames are straight and do not contact reformer tubes. Uniform firing is also a challenge because sometimes you may have more than 100 burners in the reformers. So I just put it there. Similarly, I put a radiant wall burner sketch over here with the different components. Radiant wall burners are used mostly in ethylene crackers and side-fired steam methane reformers. Uh, there are different versions of this with staged fuel gas, primary fuel gas, premix burners also, and they are especially very small capacity. So we will do more coverage in the subsequent. Burner piping is also important. You want to have a well-designed fuel system so that you can supply uniform fuel gas and fuel oil flow to all the burners. Make sure you have drains for manifold cleaning and draining. So that's also specified in API 535. API 535 also talks about properly sized control valves, individual burner and pilot isolation valves, pressure traps to make sure you're monitoring the pressure. Fuel gas piping, normally fuel gas is supplied from fuel gas drum or knockout drum with demister. Some people provide coalescer filters, piping sloped in the flow direction to avoid low points. Yeah. So incidentally, this has been deleted from the latest edition of API 535. My team told me that. Uh, fuel gas piping, again, you want to ensure that they are sized correctly. You have to provide fuel supply to all the burners, so it serves as a distribution header. You want to have a symmetrical layout. Also, a lot of places it will help if you have a heat tracing and insulation to prevent condensate formation. That's also very important. A lot of times you have condensate which can be corrosive. Some velocity guidelines from API 535 on fuel gas piping. Header velocity less than 50 feet per second, burner takeoff velocity less than 75 feet per second. Takeoff should be from the top of the header to avoid dirt or condensate carryover. Flex hoses should be protected against kinking and have drains for safe disposal. Again, these are all there in API 535. API 535 also gives you guidance on the burner materials. Fuel gas manifold and piping, normally carbon steel is used, but if you have H2S or fuel gas temperature is more than 300 degree F, use 316 SS. Or fuel gas riser pipes, you can use carbon steel, or if you have preheated combustion air, you can use stainless steel SS304, or you can use SS316L whenever you have preheated fuel, preheated combustion air, or high H2S. So that's another. They also have guidance on the fuel gas burner components. Fuel gas typically is SS310. Premix venture is mostly carbon steel or cast iron. Flame stabilizer in or cone is 300 series, or sometimes even, I think, 25 chrome, 20 nickel. Flexos internal lining, SS316L. Flexos external braiding, SS304. So API 535 does give you a lot of guidance and help. And it could be a good starting point for you. It could be a good starting point if you have a job of buying burners. You can use API 535 as a starting point. I don't know how many of you are firing fuel oil, but these are from section third edition. They have been deleted in the fourth edition. Fuel oil piping generally starts supplied from central storage. You have to have an insulated and steam traced loop circulation rope to provide any dead ends. So typically you have 3 times or one and I mean API 535 says 1.5 times, but a lot of companies provide 3 times the circulation rate to make sure there is uniform temperature and viscosity for this thing. That's a schematic of a fuel oil piping. Normally, fuel oil firing will always have atomizing steam. And this shows the oil firing valve, steam firing valve, flushing valve, purging valve, pressure gauges, and then we have the flex hoses to the burners. These are some guidelines for oil loop velocity, burner takeoff, approximately 2 meters per second, burner takeoff from top, piping heated and insulated. Light oils can be unheated, and light oil velocity around 3 feet per second. Atomizing steam, you want to have dry steam or slightly superheated steam is what you normally want to do. There are 2 types of atomizers which are used in heater industry. Mostly they are constant differential pressure maintained between steam and oil. That's typically, you want to have a steam velocity less than 100 feet per second in your atomizing steam headers. These are again the guidance on fuel oil burners. Fuel gun body, typically ductile iron, fuel tape stainless steel 310, atomizer stainless steel 304, or hardened nitrile alloy, and other components could be carbon steel. Some more guidance on wind box. Most of the wind box will have castable lining in oil firing. And the tile, as I said, has already been talked about. You can either have 60% alumina or more than if you have 90% alumina if you have high sodium and vanadium. Again, burner housing materials for different combustion air temperatures, other material parts, it's again given over here. Preheated combustion air, you use insulated carbon steel. If you have noise reduction and other things, you use mineral wool over here. Other material parts, normal carbon steel, but if you have preheated air, you will mostly go with stainless steel. Pilot gas piping. Again, pilots have become a lot more important actually because industry has been cutting down the number of operators, so they are putting more stress on automatic pilots. So pilots in the last 10-15 years have become very important. You want to have a quarter-ton manual valve for isolating each pilot. You want to have filters on pilot gas headers, Y-type strainers, and a lot of people provide stainless steel piping for extra protection. That's what is API 535. Pilots, what are the functions of pilots? It's a continuous source of ignition, and also it is igniting the main burner flame. Normal practice is to provide one pilot on each burner. That's typically the normal practice. There are some companies who don't believe in providing pilots, but even those are changing now. So most of the pilots will be fueled by natural gas. A lot of companies want to keep the gas supply header of pilot independent of the fuel gas supply. So that's another safety measure they take. Your pilot flame should be clearly visible, and API says put it in the direction of the airflow so that there is no shear stress. Here we are showing you the lighting port, scanner connection, pilot fuel gas connection over here. Typically, pilot heat release 75,000 BTUs or 22 kilowatt is what is recommended. Independent continuous air supply to the pilots. Most of the pilots have a self-inspirating air supply. You can have manual ignition of pilots, but these days everybody is going for electric ignition. You can have portable ignition also, but even then that is a manual work. So more and more people are going with an automatic ignition system with a flame rod and an ignition transformer. So they want to just press the button. Flame detection requirements, people want to put flame scanners like UV, infrared, or UV plus this thing. And they want to make sure that pilot flame is detected. A lot of times you want to have a pilot from 50 to 100%. Check that. You want to make sure that pilot is independent of the burn area register settings. Fuel valve open and close. You want to make sure that it does not go out during lighting of these things. Stable at high pressure or burner design draft. So API has come out with a number of requirements on pilot burners. And if you want to install pilot burners, these guidelines will be helpful for you. People want to remove pilot burners when it should be removable if you want to take any maintenance or something. Independent pilot gas connection, I already told you that. You don't want to have a plugging, so you want to provide dry, clean fuel gas. For flame detection, some people use flame rods, and the flame rods could be consumable because it's always in the high temperature zone. So you need to make sure that you replace the flame rods maybe every year or every 2 years. You want to replace it. Well, that's all I had for today to cover the burner components. We have about 8 minutes left, so if you have any questions, I'll be more than happy to answer these questions for you. We want to challenge us with your worst heater, worst burners, and I promise we will make it the best heater.
Yes,
So,
thank you very much for attending. We'll go through some questions. So you can submit your questions using the either the questions function or the chat. Either one is okay. All right, we have a few questions already, so I'll go ahead and ask them. Okay, the first question is between the damper in the stack versus the burner air register, which one is more effective for controlling percent excess O2?
excellent question. Because there is always a tussle between using stack damper and burner air register. The correct method is to control excess O2 using air registers. That's what you would do most of the time. Stack damper is used for controlling draft.
Okay. All right, we have another question. Okay, in the burner gas manifold pocket, in the burner gas manifold pockets are allowed, and I guess the question is, is there any chance for condensate to accumulate, maybe in the manifold pockets?
So it can accumulate, and it has accumulated. You want to make sure that you insulate and heat trace the fuel gas lines. That's a very safe practice for ensuring, because what happens is out of 365 days, you may get winter only for 30 days. So you have to make sure that you're prepared for the winter. When the temperature goes down, the hydrocarbons start condensing. So you want to ensure that the fuel gas temperature is always kept uniform and constant, maybe a little bit preheated, maybe 60 degree, 50 degree centigrade 40 degrees centigrade, whatever you want to maintain it, and maybe steam tracing will definitely help you out.
All right. We have some more questions coming in. Okay. This is a question about a pilot. Could the flame rod in the pilot replace the UV in the main flame without compromising the safety of the heater?
Again, a very good question. There are different schools of thought. There are some people who insist on monitoring pilot flames only, and they say if the pilot is there, there is no chance of main flame being going out, so you only monitor the pilots. There are some people who say no, we don't want to trust it, we want to monitor the main flames. And then there are some people who want to monitor both pilot and main flame. So there are three schools, and everybody wants to, based on their experience, based on their philosophy, tries to stay with one of them.
All right. Okay, I have another question. Okay. In natural draft heaters, such as those in a CCR platforming unit,
Mhm.
how can we ensure that the air register opening is optimal?
Oh, okay. So that's a very tricky question. Uh, it depends on what type of CCR you have. If you have floor fired burners, then it is a lot simpler exercise because the draft availability on all the burners will be uniform. So you can maintain a uniform opening of dampers or registers. If you have burners which are mounted on a different level, then typically during burner testing, because they will be sized for different draft, so you can see what setting you need for, let's say, 50% capacity, for 100% capacity. So that is basically will be, or the burner vendor can give you the draft opening versus the damper opening versus the load, and you can use that guide to ensure, or optimize your air registers opening.
All right. I think we have time for one or two more questions. This one is interesting. It's about using hydrogen as the fuel source, and the question is: have we developed burners to handle over 99.9% hydrogen? And what are the challenges to burning higher blends of hydrogen?
So I want to tell you that we developed a pure hydrogen burner almost 45 years ago in India for a chemical plant which was venting hydrogen, and we developed a burner and we fed it into the boiler. So hydrogen is a very clean fuel. I mean, people are scared, but hydrogen is a very clean fuel. The only thing is it has a very high flame velocity. So you want to make sure that you have enough fuel gas pressure, or when you design the burner, you don't get a flashback. That is one. And the second thing is hydrogen is very light, so you will need to have a special line, you know, because hydrogen molecular weight is 2 and natural gas is 16, so you can't put 8 times more,
Yeah.
flow through the same line. So that may be another thing, but we can definitely help you if you're thinking of firing hydrogen. It's a very easy fuel. People will scare you, that they need to do this, 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 but in all honesty, you don't need to do anything, or not major thing. Yeah.
All right. Well, if you have other questions that we weren't able to get to, again, you can always reach us at info@heatflux.com, or just go to our website. We can help you with any of your burner or fired heater needs. But thanks again for attending the webinar. This is part of a webinar series. So please subscribe on our website and you'll be notified when we are doing future webinars in our burner series. So there are a lot more content to cover. And so thank you again for joining. And yeah, we'll hope to see you in the next webinar.
Thank you all. Thank you for your patient listening,